Okay, so today we're going to be talking about graphing quadratic inequalities. Um, so the first one, my example, I've got y is less than or equal to 2x squared minus 3x plus 1. So before we start, though, you guys remember when we have inequalities? If I've got less than or equal to or greater than or equal to, the line is different than if I just have less than or greater than. So when is the line dotted?
When there's no equal to.
When it can't equal the line, exactly. So if it's just less than or greater than, it's a dotted line. If it's less than or equal to or greater than or equal to, it's a solid line because the line is part of the solution. Okay? All right, so we're going to graph y is less than or equal to 2x squared minus 3x plus 1. So since this is in standard form, I'm going to have to figure out my axis of symmetry. So negative b would be positive 3 over 2 times 2. I get 3/4. So my axis of symmetry is at x equals 3/4. Now this one, because it's not exactly in the middle between two lines, we pretty much are going to have to make a table to be able to figure this one out, to be able to get some points on both sides and have it be somewhat accurate. So I'm going to go ahead and do a table on this one. And I want my 3/4 to be in the middle. So I will do 0 and -1 on one side, and then I'll do 1 and 2 on the other side. So if I put in a -1, -1 squared is +1, so I get 2, and then -3 times -1 becomes +3 plus 1, so that is 6. So at -1, 6, I have a point. At 0, it's going to equal 1. That's my y-intercept. And then 3/4 is going to be the one that's a little bit of a bugaboo. But if I square 3/4, what is it? 9/16, yeah. Minus 3 times the 3/4 plus 1. So that reduces to 8. So I've got 9/8. This is going to be 9/4, -9/4. So I'm going to make it also over 8. So 18/8, and then my plus 1, I'm going to make 8/8, so that I have a common denominator. So 9 minus 18 is -9, plus 8, I get -1/8. And so that's going to be right about there. So whenever you have fractions, just estimate them. All right, then if I put in a 1, I have 2 minus 3 plus 1. That comes out to 0. Right next to it right there. And then finally, if I put in a 2, 2 squared is 4, 2 times 4 is 8, minus 3 times 2, which is 6, plus 1, so 2 plus 1, I get 3. Okay, so is this one going to be solid or dotted? Solid, yes. All right, so now I've got to figure out where to shade. So I'm going to test some points. I'm going to test, let me erase some of this here. Okay, I'm going to test 0, 0. Because that's outside of it. And I'll test 1, 1, since that's inside of it, and those are easy numbers. Okay, so if I plug in a 0 for y and a 0 for x, I get 0 is less than or equal to 0 plus 0 plus 1, so 1. Is that true? Yeah, that one's true. But I want to be sure, so I'm going to test the other one also. So 1 is less than or equal to, when we put in 1, we got 0. Is 1 less than or equal to 0? No, that's false. So the 0, 0 is on the outside or under the parabola, so I would shade underneath the parabola. Okay? And isn't that kind of what you would expect with a less than or equal to? That it would be under it? Yeah. All right. Any questions there? You guys get to do this one then. Is this one going to have a solid or a dotted line?
Dotted.
Yes, dotted line this time. You can do them on whiteboards, or if you prefer to do them in your notes, you can do them in your notes. On the positive side, after you find the vertex, you don't have to make a table on this one. So. Okay, did we find our axis of symmetry?
Yeah.
What'd you guys get? X equals -3/2 or -1.5. Okay. So since that is exactly in the middle between lines, it's not hard to estimate, and you don't have to make a table for this one. What are you going to do with that -3/2? You're going to plug it in and find the vertex. Yeah. So if you haven't done that yet, go ahead and do that now. Okay, so the vertex is at -1.5 and -6.25. I haven't seen very many graphs yet, though. Okay, so you should have had your vertex at -1.5, -6.25. So 1, 2, 3, 4, 5, 6, slightly more than 6. And then I'm going to go over 1, up 1, because it's just an x squared. Over 1, up 1. Over 2, up 4. 1, 2, 3, 4. Over 2, up 4. 1, 2, 3, 4. Am I doing this one solid or dotted? We agreed it was dotted. Okay, and so then if you test points, 0, 0 is inside of it. If I test 0, 0, I get 0 is greater than -4. Is that true? Yes, it is. But if I want to be sure, I could also test 1, 0. No, let's test 3, 0. So if I put in a 0 for the y, I get 9 plus 9 minus 4. There's no way 0 is going to be greater than that. So you end up shading it on the inside. Okay? All right. So when we do a system of inequalities, we're just putting two on the same graph, just like we did with lines, and finding where they overlap. So for the first one, y is less than or equal to -x squared plus 4. I'm just shifting my whole graph up 4, aren't I? Because of the plus 4. And then it's -x squared, so it should be going which way? Down. And there's nothing in front of it other than the negative, so I can go over 1, down 1, over 2, down 4. And is this one solid or dotted? Solid. Okay, and so if I test 0, 0 on that one, I get 0 is less than or equal to 4. Is that true? Yes. So I know that I'm going to be shading under that one. Okay. All right, then for my other one, negative b over 2a, I get a positive 2 over 2, so 1. So my axis of symmetry is at x equals 1. And so if I plug that in, y equals 1 squared, which is 1, minus 2 times 1, which is 2, minus 3, and that comes out to -4. So the vertex for my second one is at 1, -4. And again, it's going to follow the regular shape to go over 1, up 1, and over 2, up 4. Is this one solid or dotted? This one should be dotted, yes.
I don't remember ever doing these last year.
Okay, and then if I test 0, 0 in that one, I get 0 is greater than -3, which is true. So that means that I'm shading above it. And so where they would overlap is right here. Okay. Make it straight. All right. Any questions on graphing inequalities? All right. We're a little short on time, so I don't think I'm going to have you guys do one. But basically, you're just finding where they overlap. And so it's not any different, really, than what you guys have been doing so far. So what kind of paper are you going to use tonight? Graph paper. Thank you. All righty. So you